Okay, guys, so yesterday we were doing rate in, rate out problems, and we're going to do that again today. Ready, kids? Oh, yeah. People at home are wondering, what's going on? Oh, I'm just waiting for the kids to stop blabbing. Okay, now they're ready. All right, so I have a little do now for you to do. All right. It's about Newfield students, so you'll be very interested. It has to do with your life. All right, so I want to see if you can come up with expressions to find. I have different questions here. See what you can come up with. Read it through. I know the homework, the AP problems are tough. I want to see if you can get parts of them, and we'll go over some of those. Right, let me just check that. Bless you. Okay, so in this little do now exercise, 20 kids were in the building at T equals 7. I don't know why. Don't ask me. I don't have that answer. We're told the rate at which they're coming in is E of T and the rate at which they're leaving is L of T. Okay. First question. Write an expression for the total number of students that enter Newfield from T equals 7 to T equals 14. I just want to know the total number that enter Newfield. Gina. I like that. Yeah, you integrate the rate at which they enter, and that'll give you the total number that enter. Let's get that one. Ooh, nice. Okay, so yeah, if you want the total number of kids that enter, you integrate the rate at which they enter. How about the second one? The total number of students that leave Newfield from 7 a.m. to 2 p.m. Cameron. Yep. You would integrate the rate at which they leave to get the total number of kids that leave from time 7 to time 14. All right so far? I don't know. All right, now, so those two problems we found total number of students, but this next question, find the rate at which the number of students is changing. Gina. Yes. So we don't integrate anything, okay, because we want a rate. So don't integrate the rate or you won't have a rate anymore. So we want rate in at 13 minus rate out at 13. E of 13 minus L of 13. And that would give you the rate at which the number of students is changing. I can't go twice in a row. Well, maybe, if I'm desperate. The number of students in Newfield at T equals 13. 1 p.m. Looking for something different. Yeah. Oh, you got things mixed up. Gina, try that. Okay, yeah. The number of kids. Okay, yeah, because that's a really good point. Like you can, like if you, because they never name like the actual function. Sometimes in these AP problems they call it something down the line. You could think of that as being Newfield kids at time 0, right? If you want to, but you don't have to. Okay. All right. So this is the not time 0, time 7. I should have said. Anyway, so it'd be 20 plus. Uh, yeah. Plus the change the number of kids, which you get by integrating rate in minus rate out. Yeah, table 13. I didn't get that. All right, so number of kids at table 13 will be the number of kids there at time 7 plus the change in the number of kids. Next one. Write an equation involving an integral. Equation's got to have an equal sign in it. To find the time, let's say we call the time, well, we can call it X, when no students are left in the building. kind of an equation. So we'll start with an equal sign. Find the time no students are left in the building. So we definitely want to set it equal to 0. Good start. Cameron. Oh, that's good. Okay, almost. We're almost there. Everything is, oops, yes, like you said. So, read in minus read it out. We're integrating that to get the total change. Well, we want to write an equation involving an interval to find the time when no students are left in the building. So we want to know when the total number of kids equals 0. So the x, yeah, this would be the time that we're trying to solve for. So the number of kids, you know, like Gina was saying, they didn't tell us what variable to use for, you know, you could think of Newfield kids at times 7, and the way you get the change in the number of Newfield kids, your delta n, is by integrating rate in minus rate out. You know, because this is the derivative of something, if you want to call it n for Newfield. Yeah, they didn't call it anything. What do you think about that? We love it. Okay. Yep. We love it. No other answers accepted. Okay. Oh, I want to finish the problem we were doing from yesterday's notes, because we didn't do the absolute min or absolute max part. It was like part D, and I think that was messy. Yeah, and then we had that. So, and if you have a calculator, take it out. If you don't have one, I have a couple on my desk. Okay, awesome. I just assumed you did it. That's right. Tell me when that is. Oh, yeah. So that's it? Okay. Okay, so we had this problem yesterday. We started 2005. And you had sand coming onto the beach, being pumped onto the beach. That was S&P, that was your rate in. Rate out was RFP, the rate at which was removed by the tide. And we got through, we did A, right? Did we actually finish C? We did that? Oh, awesome. Okay. So now we're up to D, right? And we want to know when the amount of sand on the beach, which they called Y of T, I guess for yards, I should say, is an absolute min. They don't have to use the word absolute if they tell you it's over an interval. They just say it's the minimum. They don't use the word relative. They're talking about absolute. So the absolute min could occur at an endpoint, right? So in this case, our endpoints were 0 and 6. And we're calling the amount of sand Y of T. But it could also occur when rate in minus rate out is going from what sign to what sign? Do you know? Negative to positive. So now I got to figure out at what time is rate in minus rate out going from negative to positive. Well, remember we put the rate in Y1 and the rate out in Y2? Let me just get the calculator. You want to put rate in minus rate out in Y3. It's a good idea. That's a different one. Get that out of there. So yeah, you should have your rate in Y1, your rate out in Y2. Make Y3 rate in minus rate out. Y1 minus Y2. You want to put that in there. And if you don't have all that in there and it's too hard to do, you can just watch this part. Now, if you notice, none of the equal signs that I have on my board are highlighted. It won't graph unless the equal sign is highlighted. So the only one I wanted to graph is this Y3, the rate in minus rate out. So I'm going to go to that equals. So the other ones, if those equal signs are highlighted, if you don't want it to graph them, just go to that equals and hit enter and move. You'll see it won't be dark anymore on the equals. And the big thing with these AP problems, you always want to make sure you set your X min and your X max. So I want to set my x min to 0, my x max to 6. Because some of these trig functions are going to confuse you if you look at it over to graded domain. So I'm going to go to window from 0 to 6. Now as far as the y's go, you can fix that with a zoom fit, or you can look at it first. We're just going to look at my rate in minus rate out. Yeah, maybe I'll change the y's. Bless you. You know, as long as you set the x min x max, that's good. And if you're not happy with the y's, sometimes zoom fit, zoom 0 will just fix them for you. Sometimes it'll mess it up. But actually, it's very nice. Oh yeah, I like that. You can see it. So this is a graph of rate in minus rate out, and I'm looking for an absolute min. So I'm looking where the derivative, rate in minus rate out, goes from negative to positive. You see it? You see where it's happening? Right over there. So how am I going to find this value? Yeah, second trace, the calc menu, and then you use option 2, the 0. So option 2, 0. Left bound, just make sure you're to the left of that root. I am to the left of it. I went to second trace, option 2. I want to find out exactly where that goes, changes from negative to positive. I want to get that 0. And then guess. So that occurs at 5.117863. Okay. And I would store that because I'm probably going to need it later. You know, you're going to have to write it down, but I would store it in alpha A. So I would leave the screen and just hit store alpha A, enter. Now I got it. So now I know that the absolute min can occur at 0, 6 or 5 point, oh, tell me again, 1, 1, no, is it 1? Okay, that's good enough. All right, now we just have to compare the amount of sand at each of these times. What's the amount of sand at time 0? 2,500, right? That's what they gave us. They gave us the amount of sand at time 0 is. Now, what if I want to know how much sand I have at this time? How do I figure that out? Ashley? What do you do? Then you take your starting amount of sand plus the definite integral. Yeah, yeah, yeah. Nope, now he's going. Oh, sorry. 0, 2. Well, for this one, we'll go to this number here, okay? 0.1178. And what do we integrate to get the change? Okay, in this one, we have to integrate rate in minus rate out to get the change. So, yeah, I'm writing S of t minus R of t. You know, yeah, it is E of t minus L, but I'm going to use the names that they gave. Now, that's my work that I'm showing. I just got to get the answer now, and I go to the calculator for that. So on the calculator, you just go back. Oh, I've got it there. I'm just bringing it back. I'm going to cheat. I'm sorry, I have to cheat. Yeah, you see how I have 2,500 plus math 9? Remember, I stored rate in minus rate out in Y3. I just got to change this to an A. I stored that 5.11 number in A. Alpha A. Enter. Yeah. So, like 2,492 roughly cubic yards. And then the great part about this is then to find out how much sand you have at time 6. What do you got to do? Change the A to a 6. Now I can't just go up there. What do I do so I can go up? Oh wait, can I go up there? Oh, I never saw that. It doesn't usually happen. Okay, pretend that didn't happen. I want to bring it back so I can edit it. So I do second enter, okay, and I would just change the A to a 6, and now I would know how much sand I have at time 6, eventually. There you go. So they're really close. What's that? Always to 3 places after the decimal. So, yeah, I'm not going to remember that. Let me just see. Let me see if I put it. I think I put it here. Okay. Yeah, so for that time here, it's 2,492.369. And then at 6, it was 2,493.277. So you're comparing the amount of sand at the beginning, at the end, and where there was a relative min. So the absolute min is the least of these. So the min does occur at 5.1178. And the minimum value is 2,492.369 cubic yards. I'll just change the view. All right. Now I guess we can talk about the ones you had for homework. And yeah. Okay, so questions on the homework. Now the first two were rate in minus rate out. The last one, that mosquito problem, was just a rate. It was kind of like a rate in minus rate out already. Yep. Yeah, like general questions. If they're asking, look at how the given rates, what they're measured in. Okay. Let's say it's a rate measuring like pigs per hour. Okay. If they ask you for the number of pigs, you're going to have to integrate pigs per hour to get pigs. Because, whenever you integrate, you multiply the units of the integrand by the units of the differential, which is going to be time. So if the rate they give you is pigs per hour, and you're integrating with respect to time, that'll give you pigs. If you didn't integrate, if you just left it pigs per hour, you wouldn't get pigs. So that's one way. So whenever they ask you for a rate, you're not going to be integrating. Okay. Correct. Okay, questions? Anyone you want? Yes. Yeah. D on this one. Oh, yeah, this is a good one. So, for part D, you already know at this point how much water is in the tank at time 18. Okay, if you took the amount, because that's important to be able to do this problem. You started out with 1,200. Okay, and so the amount of water in the tank, I don't know what to call it. Did it tell us to call it anything here? All right, so like the volume of water at time 18, you had to figure out already, and that was the 1,200, the amount you started with, plus the integral from 0 to 18 of rate in minus rate out. Right. So if you got that, what was it, 1310? Okay, so it's 1310. So now time is 13. At time 18, you've got 1310 gallons of water in the tank. Then it says this rate in is no longer working. No more water is pumped in. It's just leaving. And you want to write an equation to solve for some time k when the tank is empty. So, actually, let me just go to that one. It'll be easier. Oh, I'm giving the answer away. Okay, well, okay, so you're starting a time, you've got 1310 gallons of water, and you're trying to figure out, what do I have minus? Oh, you want to know when the amount you started with plus the total amount removed. Now I forgot if RFT was negative or positive. It was being removed, so you would want to subtract the amount of water Yeah, because now that, you know what would make it easy for you to see? If I put in for rate in 0, then you would see the negative. Let me do that. So it would be plus the integral from 18, that's our starting time, to k of rate in minus rate out. So the rate in now is 0. They changed it to 0. So you'd be trying to solve this equation. Find the time where this is the amount of water at time 18 plus the change in the amount of water, which would be the integral from 18 to whatever the time is. And now you only have a rate out. And you were trying to find out when that's going to be 0, and the amount of water 0. So it might be easier for you to look at the answer like this, or just with the minus out front. No? Is that hard to see it? Okay. Okay, other questions on these? Sure. Okay, it's bad when I have the... Okay, yeah, and when they give you the answers on these keys, they sometimes give you extra work that you really don't need. Like if you are trying to find, what are you trying to find this time? The absolute min. So you want to know when, you have to figure out how much water you have at the beginning, at the end, but also when the derivative rate in minus rate out goes from negative to positive. So you would have to graph rate in minus rate out, put it in Y3, and see where it goes from negative to positive. And it's going to be this one. This is a max. This is a relative max. If you graph the derivative, they always, I don't know exactly what it looks like. Don't bother with this one. This is the... Yeah, they say, well, because their justification, they say, okay, you can have an absolute min at an endpoint or where the derivative is 0. Well, if you say that, then yeah, you got to show them both. But if you say you can have an absolute min at the endpoint or where the derivative changes from negative to positive, you just have to show this one. There's no way at a relative max you're going to have an absolute min. I always think that's so silly. So just find out how much you have at each of those times, the endpoints, and when rate in minus rate out goes from negative to positive. Just graph it, and that's the number you get. And then to get these values, you know, you just take your initial time, the initial amount, and add the change, which you get by integrating rate in minus rate out, W of t minus R of t, from 0 to that time. Okay. Yes? Was that the 2015? Yeah, if the rate is positive or negative, so don't integrate anything. Just figure out if that rate of change, the rate in minus rate out, is positive or negative. Yep. There was one of them, I know the wording. Yeah. This one with the wording, I thought was really tough. So you have this one rate, it tells you, and this is measured in mosquitoes per day, right? So this is the change in mosquitoes. This is like DMDT, RFT. It's the rate at which number of mosquitoes is changing. So the first part, show the number of mosquitoes is increasing. You just want to find out if that rate of change is positive or negative. You just plug 6 into that. And it was increasing when you plug 6 to RFT. Because remember, RFT, I know it doesn't look like a derivative, but think about it. Look at the units. Mosquitoes per day. That's like saying DMDT, that RFT. It's like the first derivative they're giving you. Okay? So when you plug 6, guys, when you plug 6 into that rate, you get a positive value. Right on your calculator, you just plug it in. So you just plug it in, on your calculator, you can do that, and you get some positive number. So you say, okay, it's increasing. But here's the thing. You can have a function that's increasing like this. It's increasing at an increasing rate, or it can be like that. It's increasing at a decreasing rate, right? Sounds very political, doesn't it? You know, like, yeah. So the fact that you found out that the rate is positive, okay, you know the amount, it's increasing, but you want to find out if its derivative is positive or negative. Basically, RFT is like the first derivative. You want to know if its derivative is positive or negative. So what you want to find is really R prime of 6. And the way you do it, you don't ever do anything by hand on these. You do n deriv, math 8. Yeah, it's a calculator problem. Hopefully you've stored R of t in y1. So you put in y1, comma x, comma 6 to see if you get a positive or a negative value. Yeah. Yes, thanks for, you were like the perfect lead-in. Can I take your lead-in? Okay. Almost always they and then what, you get a positive or negative for this? Negative. So even though the RFT was positive, its derivative was negative. So the graph of the mosquitoes versus time would be going like this. It's increasing, but at a decreasing rate. I know. Don't let that stuff bug you. All right. I want to do something that Cindy just asked me to do. You know, like I say, what is this one? Oh, okay. Almost always the rate problem is a calculator problem. But back when you were, how old were you in 2000? In May of 2000? Because I was going to say back a few times. Okay, one or two? Okay. When you were just trying to stand, kids got this problem. It was a number 4. It was a rate in minus, a rate in, rate out, but it was no calculator allowed. So I wanted to just like at least talk about it a little bit. Water is pumped into an underground tank at a constant rate of 8 gallons per minute. What is that? That's your rate in, all right? So you got your rate in, which I would probably store in, oh, I can't store it. I'm like on auto mode. You can't store that. You got to store that in your brain. So rate in is 8, or E of T, all right, E of T, equals 8, right? This is in gallons per minute. And the rate out, it's water going out at the rate of square root of T plus 1 gallons per minute. It's not bad. At T equals 0, the tank contains 30 gallons of water. So that's your initial value. Okay, let's see if we can set them up at least. How many gallons of water leak out of the tank from time 0 to 3? What would be the setup? Because you get a point just for the setup. Of what? Yeah. So we get points for writing that. You integrate the rate out. Okay? And now you'd have to actually get this. So little u sub problem, little baby u sub problem. Yeah, it's not bad though. Because think about it, you have du. Like if you let u equal the t plus 1, du is just going to be 1 dt, right? You don't need to put anything in there. Well, I don't know how many points this was. I don't think I... So if you want to integrate the square root of u, as long as you have du, you know, so you're integrating the square root of u du. I'm not going to write the limits of integration because or else I got to switch those also. What's the antiderivative of the square root of u? Ooh, I heard 2/3. Yeah, I'll put it back in there. So let's just actually put that u back in there. So you get 2/3 t plus 1 to the 3/2. That's the antiderivative. And we have to integrate it from 0 to 3. So we plug in the 3, we have 2/3, it's going to be 4 to the 3/2. And then when we plug in the 0, I should have left the 2/3 out. Oh well. Times 1 to the 3/2. Alright, so you have no calculator. And you got to get what 4 to the 3/2 is on your own. Yeah, because you have no calculator. Alright, you could factor out the 2/3. But you can't avoid it forever. I always like to do the root first. Take the square root of 4 and then cube it. You'll get the same answer. 8. So we get 2/3. Right? Power over root. It's the square root of 4, but then you raise it to the third. So that's just 8 minus... Oh, I plugged in a 0 into the t of my antiderivative. Yeah, square root of 1 cubed is still 1. So we get... I don't know what's going on there, but 14/3. That was fun. I mean, 14/3. And as far as the units go, I forgot what we were even doing. Oh, gallons. They didn't say indicate units, so we wouldn't be in trouble if we didn't write it. How many gallons are in the tank at T equals 3? All right. Well, let's call it like W of 0, whatever. But we'll just... How many gallons did we start with? 30 plus... Now, how many gallons? Remember, we had a rate in and a rate out. It was the rate in minus the rate out. 0 to 3. Now, am I going to do all this work all over again? No, you can integrate these separately. So the only thing I have to really do is integrate the 8 from 0 to 3. Because you can break this up. We've already integrated the rad t plus 1 from 0 to 3. We just did that. We got 14/3, right? So we have the 30. This is just going to be minus 15/3. You can get the antiderivative. Plug in the 3, plug in the 0, and subtract. What's that going to be? 24. Now, if you got an answer like that on the AP, you'll leave it and run away, because you don't have to do arithmetic. You don't have to simplify arithmetic. Yeah. Don't worry about it. I'm going to bug you in class about the common denominator and combining it. Arithmetic only at the end. I know you're dying to know what this is, but I'm not telling you. This is the last part. Write an expression for A of t, the total number of gallons of water in the tank at time t. Same thing we just did it before. So it was the beginning amount. No, wait a minute. 30 was just starting plus the change from 0 to t of rate in minus rate out. So 8 minus t plus 1. Write an expression. Bam. That's it. Kind of the same thing we just did, right? The one before we actually got an answer when, yeah, exactly. We had the t. Was that the last part of this? Oh, darn. I thought I was being really good. Oh, to find out when it's going to have a max? Ew. Well, rate in minus rate out is, we'd have to see when it was positive and when it was negative. Ooh. So rate in minus rate out is this. We'd have to see when it's 0. Make a little sign chart. So we'd set our derivative equal to 0. Remember, rate in minus rate out, that is... Yeah, because they're rates. The rate of change is the rate in minus rate out. Can you eyeball that and figure that out? That would have to be 63. We'd have to make a little sign chart and compare it to the ends. Oh no, 0. 0, 120. Yeah, this would be fun. Well, because you want what's in the radical to be 64, so you get 0. Square root of 64. Well, because 8 minus the square root of some number equals 0, that means the number has to be t plus 1. I mean, t plus 1 has to be 64. The square root of 64 would be 8. Yeah, we'll finish go to that one tomorrow. But you'd have to figure out if it was positive or negative, like you make a little sign chart. You could. You're actually right. You could just figure out how much you have. I was trying to avoid. I guess it wouldn't be hard to just do the chart way. You're right.